So I'm gonna keep going from where I stopped last time. I'm gonna put 1 hour and a half timer. There we go. I'm gonna delete this. I forgot to update the chats. Pretty sure that this is the function that it calls the first time there. After it adds the points to, after it adds the curve for the first time. Because I do remember going over this. So I think it's exactly the same function. It's the one that I spent a bunch of time talking about. So just gonna go over, I think A is probably the curves. And does it update this? Yeah, I think A is the amount of curves you have. And this, I do remember that this is initialized there when it creates the curve, I think. So for all the curves it has, it's gonna do the calculation there of the differences and the tilt. So I'm gonna write down, I'm gonna write down the name of this function and the other ones. So the name of the file, so I'm gonna use SkyDraw to draw this stuff. So now I'm pretty sure that those are gonna be the main, one of the main functions. I think I already did the beginning here. Trying to the main thing that is still confusing is the parts of the two different curves, because it seems it creates two different curves. So I'm probably gonna have to go back to the first iteration there, so start from the beginning. But either way, I think it makes sense to write down the names of the functions now, because obviously those are the ones that are gonna be used. And what I'm gonna do is just straight up copy the functions. And I'm probably gonna have to change them until it compiles, because I'm not gonna have all the data structures here. So I'm gonna have to see which ones do I need. I know for sure that the bev list I don't have, and I think the bev point I might have, because either the new NURB or whatever other one uses bev points or b points. I think I have b point, but I don't have bev point. And it seems that this bev list here is not like attached to anything. It's a data structure that they use from the outside, let's say. So I'm just gonna write the name of the function and the file, the path. Then once I'm probably gonna create another file I'm definitely gonna create another file just to keep track of these functions, because that's the way that I've been doing so far to make it easier to think about. In the beginning, when I was writing the function, because this is the main function that I'm doing everything over, and I know for sure I'm gonna change stuff here because of the thing that I said in the previous stream, is that there's a bunch of stuff that is just related to the state management. So I'm probably gonna get rid of this curve here, and I'm gonna replace with curves directly, and I'm not gonna use curve geometry. And I'm probably gonna try to simplify the NURBS thing. So I think it always going to boil down to the NURB thing. Like only one NURB, and then I get rid of this edit NURB thing here, and just keep this new here, which is the one that is stored, and then I put all the information here. I think that's what I'm gonna end up doing. But initially, as I was doing this, I created the general types. I think a general curve types is the first one that I created, I think. Just to put all the structs that is using there. And so here you have b point, because I think b point is used on the new NURB. Yeah, so here b point. That's the only one I have. And then later on, I put the other functions on both the curve types and the math helper. So curve types was to translate the curves struct and then the geometry. And I was going to put, I was like putting the functions for converting the functions from curves geometry. Then I realized that it doesn't make a lot of sense to copy them straight away, because I might not need this stuff. So I want to avoid, so probably here on this file, I'm not gonna put much stuff. So I'm probably gonna delete the functions that I have there already. And I'm gonna end up not using the curves geometry, because it doesn't make sense for the stuff that I'm trying to do. I'm probably gonna put everything here. I'm gonna merge this one with the curve that I have there already. And I'm gonna make the function. So, but what I'm planning to do is to create another file header in C++ file to put the other parts of the process. I'm probably gonna call bevel something because that way it's gonna be easier to know. And once I have all these functions and everything, probably gonna put them. Yeah, I'm gonna figure out because here up until this point is all the logic to create the first points and then add them to here. Which I'm probably gonna replace this like I was saying. So from this point here, what I think I'm gonna do is just first copy the functions in two different separate files. Then once I have those functions, I can call them here based on the order that I think they are called there. And after I do that, I'm gonna be able to know. I'm gonna have to think about how can I change the functions to simplify the process, so that instead of them using the data structures that they use there, I'm just gonna use no directory, nerb directory. And probably on this function, instead of returning a void, I'm going to return the nerb thing. And the nerb is going to be the thing that has the vertices. I think that's what makes the most sense. Once I get to the point, then I can go back to the array mesh thing, and I can just call this function to create the vertices, and then just update the vertices. I have to see what kind of other data they also create, and I'm going to be able to get, but the vertices is the main one because the vertices is the part that is necessary to actually create the structure. Everything else is just bonus, but obviously it's better because if you want to put texture on a curve, you need to have normals. I think you need to have UV coordinates, just translating the coordinate space for the image into the surface that you're creating. I think I showed this some other time, but I'm going to show again because this part is very confusing. It's still confusing for me, just because of the nature of the thing, but there's a function on the shaders that allows you to compute the linear interpolation of the coordinates. So you're taking the coordinates from an image and translating them into a surface. And this is what allows you to put images on surfaces using the texture functions. So it's basically this stuff here. This would be the coordinates of the image, which always goes from 0 to 1. And then there's a function where you take the whatever coordinates you want from the image, and then you put them on the coordinates here. And the way that it's gonna work is based on the linear interpolation of the thing. And there's different modes for based on different frameworks that allows you to determine what's gonna happen if the size of the image goes outside of the surface. Or the other way around, I don't remember. I think, yeah, if the size of the surface is bigger than the image, then I think you have different options to either copy the other parts of the image again or to extend the image and lose resolution, stuff like that. So I think it makes sense to write down the names of the functions now, and then after I'm going to put them on the file there, like I said. I'm just gonna write the path here. This stuff here I think I can remove. It doesn't apply to my situation there. Oh, also I should write the data structure, the names, so I can search later. This other thing is I'm probably gonna remove the type because it doesn't make sense. So add tail already have. I think initially it makes more sense. Sure, I'm gonna use these functions here probably initially. So I'm just gonna copy this function and then I'm gonna remove the parts that are related to states. But I am gonna copy like this first because it's easier. Then once I copy everything, I can think about because I'm not gonna I don't see the point in doing this stuff here because I can get the points directly. I think that makes a lot more sense. The reason why they do like this here is because of the state. So there's more situations where you're gonna have different types of curves or you're gonna have different types of things happening on the scene. So it makes more sense to create these other data structures to store additional information. This other stuff here is math related. So I'm probably what I have been doing is just converting because on Godot you have a class called vector tree, and the class overloads these operators. So subtraction, multiplication, this kind of stuff. So you just subtract directly. I think the reason why they do it like this is because probably was originally in C Blender. That's what I feel like happens here. So, and it's probably more because they decided to go with this composition approach, so they don't overload anything. So it's the same file, source Blender linker, intern. It's probably on the same file as well. I should copy here first. Same file. This one, yeah, so this one's not gonna call. But this one I remember calls. The other ones I don't remember. So I'm not gonna put them there. After putting the functions, then I have to write the. I think it makes sense to write the data structures now. So I think the minimum twist is the one that it calls there. And basically, like I said before, I need to just write the functions first, then I need to clarify the inputs and outputs of the functions to know what kind of data structures are necessary and the connection of the data structures. I'm pretty sure that he calls this stuff here. I'm not gonna write down any of the math functions because I'm gonna have to convert manually, so doesn't make sense. I think that's probably all that makes sense copying now. And it's interesting that hmm. So this is for when it's not cyclic, I guess, is equal to 0. Hmm. I think more makes more intuitive to, but maybe you can't really do that. But you make the knots there. It's whatever. So it's storing the information on this bev p. It's probably bevel point. So I think I see what it's doing here. The bev p just stands for bevel points, and it's just the points around the other points. I think it works like what I said before, but I'm not 100% sure. It's just doing linear interpolation between the points of the curve, and then based on the linear interpolation, it's calculating the rotation and other stuff to create the surface. And based on the name, there is probably from like a polygon mesh, which is very similar to the way that some of the tutorials on Godot recommend. You can use a CSG polygon mesh on Godot, and then use a Path 3D to create the mesh. So, but based on that method, people say that it's kind of slow. So I hope this one is better than that one. And I think it is gonna be better. Either way, I don't think you can avoid because dynamic meshes are gonna be suboptimal for speed because you have to. The best optimization I can do is to figure out or create the function in a way that it only updates the vertices when there's a change in position for the 2 points that it connects to. So this is interesting. So it's just calculating the resolution. And if you go with Blender and you test it out there, the resolution is just how smooth the curve is gonna be. So this part's probably responsible for that, like the names say here. So before it seems like it calculates all the values, and then this is the main one that is gonna actually create the bevel. But I do remember, maybe it happens later, maybe it happens on this function. I do remember there's a function that specifically says vertex, and I think it's on that one. So I don't think I skipped that. And this one I think I've seen already from the previous time. It doesn't have directly vertex on the function. I think this is the first one. So this is probably the one that I seen, the vertex, if I remember correctly. So the rest is probably setting up the thing first. Yeah, so this is the one that creates, I think. So it sets up all the values in the beginning and then it uses this one to create vertices. Interesting. Oh, so there are different modes you can create the curve. If you put half, it's just gonna, like it says, it's gonna make the curve in half. So the full is just a full circle that's gonna create. Yeah, so I'm gonna write down both before I go there. Curve balance, CC. So this file is probably the one that has all the functions related to adding the depth to the curve. I'm not gonna write down the other ones because I can get from the main ones. And it doesn't look like it has anything. Oh, so yeah, this probably this part that I remember. So this is probably gonna be where it keeps the vertices. So I do remember watching this. So here it has this NR based on the curve resolution. And it's times 2 plus 4. And I think 4 has something to do with the flow. It's like one of the common star SAS. Not sure why double times 2. So inside of this list is gonna have this verts. It's gonna append to the end of the list, to the tail. So here is like I think that's how it works pretty much. It's just gonna create a pointer here, and the pointer points to this stuff, and this stuff is a pointer. So this points to the place in memory that is allocated using this macro that they create. I think it's a macro, I'm not pretty sure. As a function pointer to this stuff here. It's basically the way that they create it to allocate memory. It's like their own way of allocating memory. So yeah, the FP here is gonna point to the same location memory as this one, I think, as this one. So when you change the value of FP here, you're changing this value here indirectly. Because the square bracket operator is just gonna dereference the point in memory, and it's gonna get the location of that point based on the type of the thing. So it's just like indexes on the array. So when you do this here, you're changing the values here indirectly because you're changing the pointer there. And then it's based on a cosine and sine, obviously, because that's how circles work. So it's calculating the cosine of the angle. I'm multiplying by the radius. Extrude's probably 0, I think. Or 0. We have resolution is 4. This was something that I was gonna do as well. I'm not seeing here, which is to look for the depth here. It's weird because the extrude is here, so the depth should be here as well. We're not seeing. So it might be some other structure inside of here, or it could calculate this at another point. But I think it should be here somewhere already. So yeah, not sure. And I think what it's doing is basically changing the values of the 3 points or 1 points, which is x, y, and z, each iteration based on this. It's just increasing the angle each time. So just rotating the points. I think what it's doing is just creating a circle around the points of the Bezier curve, probably. Based on the radius there. Yeah, that's what makes the most sense. So the angle depends on the resolution, which makes a lot of sense as well. So like the resolution changes how many triangles you're creating. So it is the way that I was thinking about. So based on the point of the Bezier, that's probably what is happening. I'm not 100% sure, but I think that's what makes a lot of sense. Based on where the point of the Bezier curve is at, it's just going to create a circle with triangles. And this loop here is the thing that creates the triangles. So the frequency of triangles depends on the angle there, the amount of triangles you have. I think this is why this NR here depends on the resolution. So it loops over more times, which creates more triangles. Which are going to be these points here, which are going to be the vertices, which are around the points of the Bezier curve. The only weird thing that I don't understand is where's the depth here? Exceptional handling, curve without bevel or extrude with width correction. Interesting. Also here, I think that's this bottom cap base and top cap base depends on the whether or not you have the check mark there to feel the ends of the curve, which I'm gonna have to have. I think actually I don't need to have that because on the thing that I'm thinking about doing is just gonna go inside of the sphere that I have. So it's probably either like inside on the surface, but it doesn't matter, or it's gonna be on the arrow, so it's not gonna show. But I think it's better to have, so I'm probably gonna try to keep as an option as well. Yeah, so I'm pretty sure that this is the function because of this stuff here. So this is the function that creates the data for creating the curve. And this is the main function. And this one is, I'm pretty sure, is the other one that I stepped over that also runs on the add curve in the first time there. After it creates the points for the first time, it's going to call this. I think this is going to copy the data. This is the function probably that has that create Bezier thing that is going to probably transfer the data that creates here to the curves struct. So it's building the data on this function here, pretty sure. The only thing that I have to clarify, so there's two things. One is what's the deal with the second curve there, the first time? And where is the depth here? Uh, the depth value. It seems that it doesn't have the value there. It's gonna be hard to find here, so I think I'm probably gonna have to spend time. And maybe it's not necessary. Maybe I can copy everything and then create the curve and see what happens there. I try to create the curve based on these functions that I already have and then see. Then from that point, think about. I think it would be better to have the depth so that's like it's easier to simplify in your mind what's happening. Because then I can have three or like four entry points for the main function. At the beginning, the ends of the curve, the control points in the middle, or the amount of control points in the middle, and then the depth, which is gonna be how thick the curve is. And also the resolution and the other stuff. The resolution is easier to figure out from the beginning there. Let me search what is a the fuck is a bevel? So it's basically which creates the mesh. Not sure why the name is Bevel though. What are you doing when I want you to start something like you? But I can understand what you're doing. I'm trying to. Do you know how much do you know? Do you know Godot? And do you know Blender? I am in field dev web with Spring Boot, Java, React. So basically, Godot is a C++ game engine, and Blender is a application to draw 3D meshes. Blender also has an engine, as far as I know right now. But it's basically two different applications that allow you to draw stuff on the screen, either on 2D or 3D. And what I'm trying to do is to move a mesh that Blender has to Godot. So I can build stuff on Godot that uses that mesh. Because Godot doesn't support yet the line 3D, which is a Bezier curve in 3 dimensions. And Blender does have that. So I'm trying to understand how Blender creates the 3D curve so I can extract the functionality and then put that on Godot. And the game engine is basically a collection of different softwares, let's say, like different tools and libraries that allow you to create a game, pretty much. So there is a rendering system. Usually, the rendering system is gonna, usually no, probably always, the rendering system uses a driver, which is a framework that allows you to communicate with the GPU. The GPU is the thing on the computer that's gonna allow you to draw stuff on the screen. So it has a shader as well, which is another language that communicates with the GPU and allows you to create buffers as well, which are places in memory that the GPU uses. That basically creates a pipeline that allows you to draw stuff on the screen. Then there's also physics, which basically creates the simulation of the. Like there's different physics engines that you can use, but Godot has one, and all the game engines are gonna have one. Just basically calculation of physics. So the weight of objects, gravity, stuff like that, collision, stuff like that. Then they also have a sound driver, which allows you to put music on stuff. And they have a networking thing, so you can have multiplayer games and stuff like that. And basically, Godot is, and all game engines are basically a collection of all these tools together that allows you to build games. And they also have a GUI, user interface, that makes it easier for you to build stuff from the interface. Blender, let me see if I can open the other one. Blender is an application that allows you to create meshes. It's probably the most popular, as far as I know. The most popular free one. There's other ones that are paid, but they're very expensive because usually companies are the ones that buy this kind of stuff. So there's Maya, I think. Maya is another big one, but it costs like thousands of dollars, I think, to use the license. So the Blender is the only one for free and it exists for a very long time. So it's basically this is a user interface, GUI, that you can use to build a bunch of things. And then the source code is open source. And it's basically written in C++. So the code that I'm looking here is the code that creates this stuff here. I'm specifically looking for, so you can select and delete. I'm looking for, when you click add here, you put curve and you put Bezier. It creates this curve here. And then if you go on the data here, the geometry, and you change the value of the depth, it allows you to have a curve on 3D. And if you put few caps here, it completes the cap, and the resolution makes it more round here. So I'm trying to figure out or understand how they do this, the whole functionality, to add the curve and to add depth, because Godot doesn't have this stuff here. Maybe I can open Godot as well to show. And if you want to do similar stuff on the front end, you can use a library called, or a framework, I think it's more of a library called 3JS. 3JS I think is the best library on the front end you can use to create stuff, to draw stuff. So Godot is pretty much this. There's a bunch of projects that I have here. So select one, it's gonna show. Yeah, no worries. So it's basically this, what Godot is. And it allows you to put a bunch of stuff here, and then you can create games. And if you click on play here, you can see like either games or applications. And there are some tutorials from the person that's one of the people that developed this. I think there's a playlist where he shows a bunch of things that you can do. You can build with this. Here is nothing because I'm just testing things out because I'm changing the source code so that it works for the kind of stuff that I'm trying to build initially. And what I'm trying to build initially is the stuff that I build on 3JS, with 3JS on the front end. There's also another library called React Refiber if you're using React. Yeah, with 3JS. And there's other libraries as well that I don't remember really well, but I also used. That allows you to draw 3D stuff on the browser. But you can also use C++ and then on Godot, they have an option for you to export for the web. So it uses WebAssembly to create a bridge. But the reason why I'm doing C++ now is because C++ is a lot faster than the browser. Gears are very slow and you have to manage a bunch of stuff from the websites using React, which is not very good. So C++, I thought that it's probably a better choice to continue. That's basically what I'm trying to do now. Try to use Godot to do this. But in order to do this, I need to be able to do 3D lines. So this is one of the options that I put here. And the way that these curves work is based on Bezier curves, which is a polynomial equation. Yeah. I mean, it's very good. Everyone uses, so it is very good. But the purpose, I think, is not like it wasn't built with this in mind, I think. So it's not very. Yeah, I like React and Next.js and this stuff. I think it's a good framework. But for this kind of thing, I think it's probably not very good. And I didn't test the other. I tried to do it with. I forgot the name of the other one. And what's the name? I tried to do it with Solid.js as well. Solid is like a React with different state management. So I tried to do it with Solid and I tried to do it with Quick as well. Quick is another framework that like it allows you to use a React kind of way, like components from React. But it's different because it synchronizes the state of the web with the server in a different way. So it hydrates your page dynamically based on user interaction instead of hydrating everything at the same time. And this makes it a lot faster, but the problem is that it doesn't serialize. Like when you serialize JSON, which is what they use to update the hydration, it doesn't allow you to post pass classes. So I had a problem with that. And I tried another framework that I forgot. But also it wasn't very good because Vercel didn't support and I was hosting on Vercel. You can create stuff for the web using C++, but I'm not really sure. I never tested, so I'm not really sure how it works. But after you make a game on Godot, you can, or make application, whatever, you can go on project settings. There's not project settings. It's project exports, and then here you can add one like a framework. So if you go to web and you export whatever you created here, it creates probably an HTML page, I think, that is probably gonna put your stuff on the web using WebAssembly. So you can use WebAssembly to code stuff on C++ or Rust, these kinds of languages, to put stuff on the web. But it becomes kind of harder to integrate that with React because then you need to use some libraries and use async to load the stuff. So it's kind of more annoying, but it's faster. So yeah, React Redux is very complicated as well. It's very painful. No, this one, the one that I was showing is one that I hosted on Vercel. You can see. And I never tested this. I'm probably gonna test this at some point in the future to export like this, but I'm solving all the other stuff now. But at some point, I'm probably gonna do this. So the data is gonna be the vertices. It's doing the same thing that it does on the other spots. And it's probably because of the control flow. I think that's what makes the most sense. So it creates this other pointer to and makes it point to the same place that this stuff is pointing to because it depends on the control flow, I think. And then inside of this function is going to use this pointer to actually put the results data, I think. After it does the calculations, it stores everything on the data. And here is from the other function. Whatever. It's 13 steps. Physical data. Yo, thank you, man. Yeah, so this steps is just the based on this NR here, which I think is based on the resolution there from the other functions. It's probably gonna be important. True. So I think this is obviously like the name says there, is building the indices. So the index is optional, but I think it's also better to have if you can. Because the index is just the index. So you have a, not sure if all situations are going to be like this, but probably the main ones or the most common ones are going to be, you're going to pass the data. The data for the points is going to be a vector of floats. So each 3 floats is equivalent to 1 position. And on OpenGL, use stride to specify to OpenGL how to use the buffer. The buffer is just the data, which is the array of floats. And then you can have the option to create another array of numbers that are going to be integers or unsigned integers. They are going to be the indexes of the positions. And if you do that, it allows you to optimize because some triangles have the same point. So if they share the same points, it becomes redundant data from the first array of vertices or array of floats. So if you use indices, in some situations allows you to optimize because you remove all the redundant points. You just reuse the same one based on the indices. I'm not really sure. So someone's asking how can I be advanced level programming? What should I learn? Like I think it's just subjective. It's too subjective of a question. Because like what does advanced mean? And there are several different skills. So I think it's like the, let's say wrong kind of question, but like it's not. I see. It's not that it's wrong. Is that I think it's just a different kind of mentality because like if you're thinking about being advanced level, you're thinking about the end, and you should detach yourself from the end because you need to imagine like imagine as if you're gonna do something forever. I think that's the best way to put it. So like it's not about the end goal, it's about who you become in the process and whether or not you're aligned with that. You want to be aligned with that. So that's much more important. So like whether or not you become advanced is outside of your control because like life happens, and also like, arguably everything is predetermined because of genetics and everything else. So the more you attach yourself to the results, the weaker you become because you don't control these things. So it doesn't matter whether or not you're advanced. It's more about who I want to become, and that's gonna be like a consequence of your daily actions. So that's much more important. So I think that probably a better question is like, what kind of things I want to build, and why do I want to program in the first place? Like, why is this important to me? Then from that point, you reverse engineer the path instead of asking like, 'cause if you think about it, like advanced is more comparison. So, and it's always gonna be like to a certain extent subjective. And even if it wasn't subjective, it's outside of your control. It's like trying to be the best at chess. It doesn't work because it's just genetics from a certain point. It's just gonna be talent. So I think it's more it's more rational to ask yourself like, okay, based on the probabilities, if I work my hardest at some points and it's still not the best, is there a way for me to sustain myself based on those things? And if there is, then and if you really like to do that thing, then it's worth it to do it, because then from outside of that is outside of their control. But yeah, I think that's how it's probably the best way to think. So it's like a paradox. Hey man, what's up? I think it's very similar to like the money mentality. I think that's it's probably it's not a very good answer because obviously there is objective things you can do to become better at programming or anything. But the problem is that like I think it's the wrong mentality to have because it's just like asking yourself like how can I make as much money as possible? And usually people that make the most money don't think like that because money is the fact, not the cause. So if you're thinking about the fact you want to have and you're focusing on that fact, you really can't control that. So it's always gonna fail regardless of what strategy I give you because you're coming from the wrong position, I think. So I think it's the same thing with like levels of skill on something. It's slightly different, but probably the same thing. Yeah, trying to trying to convert some Bezier curve from Blender to Godot. Oh fuck! I skipped the thing. Let me go manually. I think it doesn't matter that much. I already have the names of the functions there. I think that's pretty much. Probably now the best thing to do is just copy this stuff. I'm thinking about. I'm thing is, it's kind of hard to make a video about this, and I'm not really sure if people are gonna watch. So it's kind of hard to give practical examples. And if you talk about the theory, I think most people don't get it because they have to go through the process themselves to understand. But I am thinking about like creating or doing a live stream explaining how to learn stuff, how to learn coding fast. But I'm not really sure if I'm gonna do that because it's probably not very productive. I think it's one of those things that the people that should, the people that the advice is gonna be good, they're already doing this stuff, and the people that uh, need the advice are probably not gonna spend the time listening. So I think it doesn't make a lot of sense. But maybe I'm gonna do it for React. Like explain, I might do, this was what I was thinking about as well, like going back to studying React source code, because now I think it's gonna be easier to figure out, but no, it's not for animation, it's for, because Godot doesn't have line 3D, so you can't really draw if there is no mesh for line 3D. There is a couple of ways you can do it that I've seen, but it seems that they're not very good. So I'm just trying to, and I want to have access to the generation of the vertices themselves. So what you can do in Godot, you can use something called array mesh. So we're gonna be on the primitives. I don't remember really well if it is on the primitives or not. Yeah, it looks like it is not here. This is from another thing as well. So let me see. Let me remember. There's a graph edge 3D or graph nodes. Was third party. I forgot where I put this stuff here. Or actually Brahma. Yeah. So here's gonna be easier to find. I think it's on. Oh, it's on nodes and edges. So it's basically mesh. Is a mesh instance 3D, and then the mesh instance 3D has the mesh. Can't remember right now, but basically, this mesh here is gonna be an array mesh. I can find here. And the array mesh is a class that allows you to pass points to Godot or vertices. Then from those vertices, Godot's gonna create the position or create the mesh for you. So that's pretty much what I'm trying to do. I'm trying to get the vertices from Blender to use on this array mesh class, so that I can create the mesh that I want. So basically, create a system where I'm not sure if I'm gonna create a system, but probably in the future to like take stuff from Blender and put it on Godot. Yo, thank you, man. Thank you for the message. Yeah, it is really difficult to understand. So the way that and this is something that I learned from previous times of trying to do this, like what you should do, actually, like I think on Blender I kind of got lucky because it's like they do have this stuff on the documentation, but it makes it a lot easier if you know how to set up the debugger. I think that's one of the main parts, because then obviously allows you to step over during the runtime, which makes it a lot easier to understand. And I did some streams explaining. I think the first stream that I did on Blender, I explained the build process and how I made this work. It's basically on VS Code here. You have two different files. The test.json is the one that runs before the debugger. So here is just running a shell command, which is basically just running the thing from here. Would be like equivalent from running the command from here. And all you do is just run the make bat file, which I also explained. I went over, I studied myself on the first stream. The microphone was kind of shitty because like I don't have control over this. Sometimes it's like becomes noisy and there's no way for me to know. But in the beginning it's understandable. So you're just running make bats. So it's as if you're running like this. But VS Code is gonna do that for you, and that's the task.json. Then on the launch.json, you put inside of these configurations here, which is an array of objects, you're gonna put the configuration you want. So in my case here, the Windows is this configuration here, and the type is gonna be the one that determines which debugger you're gonna use. So if you compiled with the makebat that I said there, it's gonna use the VS or the MSVC compiler, which is the Windows compiler. So you have to put this type here on the launch.json to make it work, because then it's going to be able to load the symbols from the executable. The program is the path to the executable, final executable, which is going to be one directory up from the source, and it's going to be whatever on this path here, relative path, based on whatever type of build you're doing. So if you're putting debug, it's going to be probably this one. Then here you put the pre-launch task, which is which task from task.json is going to run before it launches this stuff here. But basically this is the main one. So as long as the executable has debug symbols in them, and the type for the debugger symbols is correct, so it's the correct type of the compiler. So for this is going to be MSVC compiler, so if you're running on Windows. And this type here is for GDB. If you're compiling for Linux, you just put this type here. It's pretty much the same thing. And the pre-launch task is optional, which is the stuff that if you want the code to compile each time before you run the debugger, you just put whatever stuff you're using to compile the code here. So basically this will allow, another important thing is to put the stop at entry true, because then it's going to stop at the very first function of the program. So this is like the first setup you do. Then after you do this, it depends on what you want to learn from the thing. So obviously it makes a lot more sense to focus on only one small thing that you want to learn from this code or from the application. Then after you figure this out, you go straight for what you want. And the way you do that is usually going to be by searching for tooltips, because tooltips are the most descriptive. So it's easier to find stuff based on the tooltips. Obviously you can search for the names here as well. Like for example, I can see texture paint, and then I can go on the source code here, go here, and then texture paint. And then what I did, and probably what I always going to do with when I'm learning this stuff, you just search by the pattern here based on whatever you find there, and then you put breakpoints on those parts of the code. And then you just press F5 until you get to that point. And then from that point, start analyzing, because then it becomes easier to create the connection of what's happening on the code and what should be happening on the user interface. So obviously first you should learn the basics of how to do everything and to do whatever stuff you're trying to learn. Then after you do that, you search for the tooltips here. So in this case, it would be shortcut Shift A, put the breakpoints, and then after you know how to do it from the GUI, you just step over on the code. And then what you're trying to do is just narrow the space of search to the stuff that matters to you. And then you have to keep track of the data structures. So here, I usually create these flowcharts here. You just keep track of the data structures and keep track of the functions that are used on the whole process of execution. And then slowly, like, you're gonna clarify. So you have to go a bunch of times. And in the beginning, it's gonna be very hard because you don't know anything, but then it gets easier and easier because each time you go through, ideally you should be trying to understand functions that don't depend on anything else. So functions that are only have straight, like, simple data structures, for example. So I think this would be a great example. So like this is one of the functions you could try to understand because this doesn't depend on anything else. Then once you understand this or have a clear picture in your mind, what's roughly what's trying to do, you can also use ChatGPT obviously to search for or to try to understand. Then it becomes more and more clear. So next time you go over with this debugger, you're gonna remember that, oh, this is the function that is being called there. So you kind of already know what's happening. And the more times you do it, then the easier it becomes to understand everything else. Then with that, you're always gonna be like you are able to expand and becomes easier and easier each time. And each time you go through the cycle, it's gonna become easier because you're gonna have a reference frame of the other times, and you're gonna start learning the fundamental patterns. So for example, in Blender, because I studied Godot first, I already had an idea that this, like, it would be a class or a struct that's used to manage data on each part of the section here, and it makes more sense for each part of the sections to have its own logic, let's say. And then whatever shows up here that changes is going to be basically symbols that replace the data structures at runtime. So like you use on one object to show up this stuff here, and then whatever shows up here depends on the data that changes on runtime for that object. So this would be like a fundamental pattern. So each time it becomes easier and easier to understand. Just like everything in life. Usually it's very painful at the beginning, then you reach thresholds. This becomes a virtuous cycle. And the thing that you're gonna learn depends on what is important to you, because you need to, there is a risk because every time you learn something, you're investing time. So, but as long as you're learning something that is important to you, then it doesn't matter because obviously it's important to you. So it's worth spending the time. No, I'm doing, so the way that I'm thinking about it, and this is another thing that I've been learning and becoming better at. So, which is something that I initially struggled, and I still struggle a little bit with this, but I'm becoming better. It's just like the first, the way you should think is always to brute force first. So, because usually the tendency is going to be for you to think about everything, and that's going to demotivate you from doing it. So, and obviously it's going to depend on your goals and everything else. So I might not convert everything, but like you should have a paradox in mind. So like try to do things in a way that you keep in mind that potentially in the future you're going to try to scale that. So like I am thinking in a way that eventually potentially would make it easier for me to convert other stuff. But initially that's not what I want to do. So it's both like the high level and the low level, let's say, like it creates a funnel where you're simultaneously thinking about the overall bigger picture, but you're focusing on the micro aspect. So right now, all that I want to do is to pass the curve. But I am thinking about, like, if I want to do other things and pass everything else, do I have a structure that makes sense? It's gonna make it easier in the future in case I wanna do that. So it's like trying to achieve both things. Obviously, sometimes you can't do that, so I have to compromise. But that's how I'm thinking about now. So the way that I thought about is like, uh, try the easiest thing first, which is just copy everything. But then I realized that this is not very good, because the more you copy, there's a gradient. So if you try to copy at the one spectrum of the gradient is gonna be, you just copy Blender entirely and you just put a folder here that has the whole source code for Blender. But obviously the downside of that is that you're not gonna be able to merge that with Godot, because it's two different things. So the other end of the spectrum is like you copy character by character of what you want to do, but then obviously that's too slow, because it doesn't make sense. Like, why reinvent the wheel? You're gonna waste time. So obviously the best approach is gonna be somewhere in the middle, and this is what I was thinking about based on the previous stuff that I learned. So I decided to just do like function by function first. So I keep relatively the same kind of path, but then I decided to not do it exactly the same, because it doesn't make sense. Because the folder structure for Blender is going to take into account the way that they manage the context for the whole application. And that's not what I want to do. I want to remove the state from Blender and just extract the stuff that I want, which is the vertices. So it makes more sense to try to simplify as much as possible the folder structure and the file structure, so that I have only the stuff that is related to what I want to achieve. Then after that, I created this because it's the simplest that I can think. And then I'm just going over with the debugger, and I'm trying to capture what functions I think are related to what I want to do and what data structures are related. And that's why I created on separate files here, because it makes it easier to think about. So I put like all the data structures on this file. Initially, so for each part of the process, I created a different file to make it easier to track on my mind what each thing is related to. So this is usually the problem when you try to copy, because one thing is going to depend on another thing, and it becomes very big. So you're just trying to minimize the amount of dependencies and coupling you have in the beginning. You should just copy the stuff that you think is essential. I'm not sure if I'm going to be able to achieve this, obviously, but that's kind of the idea that I'm trying to follow here. And then once I get to the point where I think I have all the functions that are related to what I'm trying to do and all the data structures, then I have this entry point function that is here. And then from this entry point function, I use all the other data structures and the other functions that allows me to have inputs and outputs. So I determine what kind of state I want. So what kind of thing I want to input here, and then what do I want to extract. And this function is going to be the main entry point to interact with the other stuff. Then once I get to the brute force solution, where I have the entry point and the inputs and outputs, and I understand how the data structures are related and the functions are related to the stuff that I want, then from that point I can test. Then I see if it works. If it works, I can continue the cycle of iteration of improving on what I have and simplifying. And by going through this process, the next time if I want to convert another object or another mesh, I'm already going to have an idea of how it works, because it's basically going to follow the same fundamental patterns. There's going to be a distinction between the state management of the application as a whole and the objects, the functionality and structure related to creating the vertices. So the next time I already have set up like in a way that's it's going to allow me to, all I have to do is just create another folder here. It's going to be like a similar thing, or create different files. Then I already know that there's going to be functions related to the object. There's going to be RNA and DNA. The RNA is going to have properties. There's probably going to be another structure that is going to be responsible for providing read and write operation to the attributes of the main structure that it's going to have. If the structure was updated based on versioning, there's probably going to be integration from the previous one with the new one. So those are the fundamental patterns. It becomes a lot easier to figure out after. Yeah, that's what I'm saying. In the past, while I implemented graphics, I studied cardinal splines when I needed to connect nodes with line. Yeah, so this should make it easier for you to understand in the future, because I already have previous knowledge of how to do things. So it becomes a lot easier to look for, to spot things that might be related to what you're trying to do. But obviously, I don't know if this is going to work or not because I didn't test, so I might change my mind on this stuff. If it doesn't work, I just find, because this is the thing, it's like you can never lose, you can only learn. And it's not like you have a choice anyway, so like the only thing that matters is having an awareness over whether or not like you're congruent with who you want to be, because it doesn't matter if you get there or not because it's outside of our control. So, and if you like make mistakes and if you can't do it, then it isn't like you would be able to do it if you didn't try. So the worst thing that is going to happen is that you learn, unless you're trying to do something that is really risky, in which case you can die or have unrecoverable injuries. So it just comes down to the calculation of whether or not is that important to you. Because in such situations, even at death, it doesn't make sense to not do it because if you didn't do it, then it's just an illusion that you would be able to survive. But realistically, like there are things you can't really escape from, I think. You have to confront. So obviously, it's always going to depend on the circumstance. So I think that this is the final function that I remember. So probably this one is going to be the one that has. Now, all the other ones are probably important as well because they set everything up in the beginning. So I'm probably going to have to go over a couple of times more to clarify the stuff that I'm thinking about here. The main 2 points is the first part there where it seems that it adds another curve. Not sure how this works. And then the second part is figuring out at what moment is gonna get the depth that has there on the front end to calculate the data there, to change the data. But I think I'm gonna translate the functions before that, I think. So next time, after, I'm probably not gonna do it today, but probably tomorrow, I'm just gonna translate all the functions that I have here that I wrote down. Yeah, Blender does use a unique function notation. I think I think it's, yeah, it makes sense because it makes it easier to figure out what each thing is. So like, most of the functions that are probably all the functions that are related to RNA have the prefix in them, RNA. You're talking about Camo case and Pascal case. I think that it's just a matter of preference. And here's both Camo case and Pascal, which is kind of weird, but this one, like, I'm not really sure if I'm following a standard as well on Godot, but I think I am, because it seems that on Godot they use Camo case to create classes, and then they use Pascal case to create functions. So I'm trying to go with that, and I think it really depends on the language. But it's just one of those things because everything is a symmetry, so it's gonna be like the reason why this exists is because of the symmetry. So just people that select what happens there. So on one end of this spectrum, we're gonna have Camo case, the other one we're gonna have Pascal. It's probably related to the density of the language. So there's something to do with that because it's like symbols. So Python is like I think Python is Pascal case and JavaScript is Camo case. So they're in different sides of the spectrum of the symmetry. So Python is more rigid, JavaScript is more composed. And it's just a reflection, I think, of the people that create this stuff. Yeah. But I think I prefer, like, if you think about it, like, if you have an option of two ends of the spectrum, one you have, like, all functions are just letters, for example, or, like, basically the compiled code in JavaScript, or all the functions are very descriptive and very long. I think I would prefer very descriptive and very long because it makes it easier to understand. So if you try to read the functions from the compiled JavaScript code, it becomes very hard. So I think I'm more on the descriptive end of the spectrum. But obviously, like everything else, there's gonna be like a middle way. This one has names here, but whatever. Probably on the other files. Like trying to understand this stuff here is a nightmare. I think this is just setting the attributes on the mesh. We're just not gonna update them. So here, this is probably the function that I was looking at. So on another function, it's probably gonna update the positions here based on the data before. Yeah, so this is definitely the function that I was looking at. So the DL is ultimately the stuff that has the data or that has the vertices, and the data is gonna be here, and then it's gonna use this to write the positions on the mesh. So the data is the stuff that matters. But I'm not really sure if this is also important. I think it is, probably. I'm not sure if this, like the purpose of this is just to translate the data from one place to the mesh there, or to they add other stuff here. But I think it's easier to just think about the mesh, so probably copy this stuff here. Mesh calculate edges. Probably copy all this stuff, then try to implement, like I said, on the brute force way. Just calling on the functions. I'm probably going to delete everything that is related to this read and write stuff, and just copy the this thing that has the data, and yeah. I think I wrote down this one. Another thing that I think is important is that usually I'm careful to, especially when you're looking at applications like this, to assume that I'm right on the first time. Like sometimes it does make sense because people make mistakes and also because the way things evolve and stuff like that. But usually I try to assume that people that created the software are probably more correct than I am, because this is another thing that is very common and I do it all the time as well. Because you usually think that you know everything. And usually people, especially that created this software, is like a bunch of different people working for a bunch of time. So they probably had problems that you're not aware of as well. And also, like, especially the software that, which is another reason why I think is very good to try to do this kind of stuff here, to like just manipulate the source code for from these kinds of software that are open source. Because not only the people that build have a lot of experience and went through a lot of mistakes and then they learn from those mistakes, but also because they expose the software for a bunch of people. So you're taking advantage of the computation of the collective, let's say, because everyone uses the software on different operational systems and different stuff like that, which allows you to see the mistakes or the stuff that can potentially happen uh, when you have several different people with several different systems using your stuff. So usually I try to assume that's the way that they did things is probably like, if it is not the best way for me, there is definitely a reason behind it. So it's very good to learn from. It is tricky sometimes though, because people do make mistakes. So sometimes they are wrong even though they spend a bunch of time. And this is very common as well in science and everything else like that. So this is another fundamental pattern that people, on the same way, but this is more when it comes to science, I think. I haven't seen too much, but it probably exists everywhere as well because it's just human nature. But people also tend to make they tend to make whatever is true right now like a religion or a cult, and that this happens with science. I think it's happening with science now, and it happened with religion on the past. But it's like the same fundamental pattern that it's just because it's like the natural default state of the mind is to try to rationalize whatever it worked for it so far, and then people get into these vicious cycles because they're always trying to remain in their comfort zone. So the more time you spend believing in something, the more likely it is that you will believe in that, which is a paradox because like the Dunning-Kruger curve, like I think is like an endless thing because it becomes harder and harder, especially if you are proven right a bunch of times, to change your mind over that thing. But it might be the case that, and it's probably always the case that you're never 100% correct on anything because reality has infinite potential. So like the paradox is the closest approximation of balance because you both have to believe you're right and understand that you're not at the same time. So I'm gonna stop here. I think I already got the functions that all the functions that I wrote there are probably all the steps. Maybe let me continue. So I'm gonna see if there is any other ones outside of this one. But this is probably the main one, and So apparently it doesn't do anything for this circumstance. But I do think that this function that I just saw is the main one. So now it's going to set the mesh. This is probably the one, the member variable of the curves. So the final, like the last function that I wrote down there is the one that creates the final data, I think, for the vertices. So all I have to do is just copy all the functions, change them enough so I have all the structures needed for all the functions, remove all the stuff that I think is necessary from the functions. Once I have all of them, then all I have to do is figure out the pathway to connect the first points that it creates, and then how the data is going to change across the functions to create the curve, the 3D curve. Once I have that, I have the final function that is the entry point with the inputs and outputs. I can put that function on the other class that I have there, and then test to see if it's going to create the vertices. And if it doesn't create, what I'm going to do is obviously go through the cycle again, and I'm going to try to do this as long as possible. But if it becomes like, if it takes too much time to do this stuff, then I'm going to think about if there is another option. Because also, what I can also do is just try to get it from the 3GS, which is the way that they use on the front end. And I've seen the functions a little bit from 3GS. They use friend of frames to create the 3D curve. So there's another option that I can do. And another option is just think from, do the approach that I was I talked about, which is just draw the circle and then calculate the path across the line and then draw the circle multiple times and see. I think that's the easiest way, but probably not the best. So I think it's much better if I make it work with this one. So I'm going to spend a bunch of time on this one probably, because I think it's worth it. And I just kill two birds with one stone because I learned Blender as well, which is another very good thing to know. So here it seems that it's everything that is important there is done. So now, yeah, so now it's just the remaining of the cycle there. So here's pretty much the end point when it gets to this part. And this, even if it works here to go over, it's just going to be the remaining part of the cycle. So yeah, it puts another breakpoint here, but I think it doesn't matter. It's just going to be, like, if it is, it's going to be the same function from the previous time. It's just copying the curve. I think the main stuff is, the important stuff was already done. These ones are just the same ones that I've seen on the other one. I think this happens each time that it updates because it's related to the way that they manage state. So they're just updating the other data structure, the cache here that they have, each time that you change there. So that the next time on the iteration, you just use the cache instead of going to, yeah. So this time is just copying the data to the cached thing there. But the main part is over, I think. This is all those functions that I wrote down there. I'm just gonna press F5. And now it has the thing here. Yeah, so what I'm gonna do is what I said. So based on these functions here, just copy everything to the other one, remove, or just do enough stuff so I can compile everything on the other one. Then I'm probably gonna review a couple more times or go over with the debugger to clarify this stuff about the depth and the second curve on the first part. Those are the main points of confusion I have right now. But I think at the end of the day, it's just gonna be to translate the data from the points on the new NURB data structure from the beginning to the data to bevel list, I think, data structure on this one that has the data for the vertices, and then remove everything related to state. Just get put everything on the data. It's probably going to be a vector or an array of floats, which I'm probably going to make a vector on Godot. Once I have that vector, I can just return that vector on the main function that I have there. So the inputs are going to be the points. I think initially I'm not going to put any inputs. I'm just going to make it easier, just going to put the way that it is there. If I see that it works, then I'm going to do the process of making it more simple. And then I'm going to have to, the tough part is going to be to figure out like how to add more points, because the breakpoints are kind of annoying. If you press E here, if you select the thing on the edit mode and you press E, it's supposed to, it does add another point to the curve, But the annoying part is that based on the breakpoints that I put there, it never stops. It doesn't allow you to get through an end, let's say. It always stops the cycle. So I think it's going to be kind of, it's going to be more annoying to figure out how to merge the functionality that I have so far with the functionality to add a new point to the curve. But if I can't do that, then all that I'm going to do is just like expand based on the calculations that I have there. So I can, I'm going to spend a bunch of time understanding how the vertices, final vertices are created. If all of this works, obviously I'm not really sure how it's going to go, but if all of this works, then like I'm going to have all the functions that create the final vertices, and I can spend a bunch of time understanding how they are created. The main thing that is confusing to me is the rotation that you need to have to create the curvature, and how they create this with triangles. So I think once I understand that from the fundamental first principles, then I don't need to spend time thinking about their stuff, because all I have to do is just search for how the Bezier curve, like how to create different Bezier curves based on the equation. Then you put that on a function. Then based on that function, you just add the extra functionality to create the data from the points of that the function is going to create. So I can do it. I can do it other ways after I have the first part, but not 100% sure if it's going to work or not. But that's what I'm going to try to do now. So I'm not sure when I'm going to stream. If I stream tomorrow, probably I'm going to still be doing this stuff here. So yeah, see you next time.